Today we're going to introduce a little bit on Flutter, and also something about RISC-V, and hopefully you can grab the opportunities around RISC-V and Flutter. So my name is Liang, and then I'm a software guy. I used to port all the VMs and compilers on different architectures. I'm the founder of Deep Computing, and then I founded a company about RISC-V, and during the COVID, so very risky. So, and because I'm a software guy, so I never do hardware, particularly myself, and this is my first startup doing hardware, and that's Alan Key says. I'm very serious about software. So before, we always think, oh, we are a compiler guy and VM guy, and then we say we're the best software in the world, because sit on the bottom of the stack, and very powerful. And then now, and COVID, I sold my software startup. Then I start doing hardware and losing all the money on the hardware. So that is Alan Key's indication. You're serious? That means you're going to lose money. So, but anyway, and RISC-V, I think most of people probably heard about it. If you've not heard about it, then basically it's a comparison to x86 and ARM. And what's the difference? Because it's open, belongs to anyone who understands it, who can contribute to it. And if anyone interested, go on to the RISC-V.org and join the community and start contribute. And then they have a very customizable architecture, and all different industry can contribute all different profile and basically it's instructions and for their needs besides the foundation one. And because it's community maintained, just pretty much like Linux, that means that it's going to live forever. It's founded in 2010 and it's been 15 years. So what actually is RISC-V? Actually, it's pretty big dreams, I guess. It's our hope, whoever work on RISC-V is pretty similar to Linux 30 to 40 years ago, saying that. And besides Windows and ULIS, they want to be 1/3 of the market, but actually Linux is more than 1/3 now. So and you can see all the RISC-V members are all famous members. So they somehow work on RISC-V one way or the other, open or closely, and there are a lot of opportunity around it. And generally saying that the whole ecosystem we still underfunded. That means that still needs help, and probably some people will still give a bounty program for part-time to contributions. So do pay attention to it. So for the past 15 years, the ecosystem grew pretty good. So from the tool chain support all the way the hardware up to the application side, and then it's not too bad. And literally we think that every layer we have them all, but is it good enough? Answer is no. And compared to x86 or ARM, we're still probably lagging behind. And on the hardware side, so I make Deep Computing makes laptop, and now we all tend to focus on RISC-V more. And then we decided to only make motherboard for framework, which is framework is you got a laptop, you can swap all different architectures laptops. So do come to frameworks booth or RISC-V booth to see how you can swap the board. And then also it's repairable, upgradable. The reason we choose to partner with framework is that because every 6 months we have a new RISC-V SoC much more powerful than before. Then we have main board, different main board every 6 months. So it's pretty amazing. So the latest one is the last year we launched the 8-core 2 gigahertz of 64 DDR and then 50 TOPS AI. So you can literally run Llama 7B model on it and DeepSeek model on it. So the RISC-V the vision is all about open source and open. So, and we're trying to achieve, at least for deep computing, we're trying to achieve is the most Linux friendly hardware, ISA. So, which means that we had to do a lot of open source, more than Intel, more than ARM. So, which including on the server side or any data center side, and even a small board, then we had to have open PMC. And then for the bootloader or in the x86 or ARM side, we have EDK tool to compare to it. It's all open source. And then because we still aim one image similar to x86, one image, ISO can install onto all the hardware. That means we had to get ACPI to work. So besides that, then why we aiming at best for Linux? So we were trying to have all the kernel upstreaming done before the chip comes out. So basically, and once upstream done, that means that you can upgrade your distro, Linux distro, without any hassles. So the most difficult one, especially for desktop or laptop, in this GPU. So we are working on a project we trying to do a low-end GPU, which with the driver, firmware, everything open source. So that means that no one had to suffer that what Linus been saying, the GPU driver always a problem. So, and exactly the same as AI now, because they're very close, just like siblings. So, and back to Flutter. Why is Flutter? Because for stack. And Flutter is just like a graphic stack, like Linux distro in traditional desktop. You have KDE, which is based on Qt, your GNOME based on GTK, and then you have Mesa and Wayland, and all these, and sit on top of the GPU drivers. So Flutter, what it is, actually Flutter is originally from Google, and it's been always a competitor for Android since it's born. So, and the history of Flutter is that it's a JavaScript. Nasbet is one of my good friends, which is back in the old days of the Java VM. So he joined Google 2006 and started working on the JavaScript V8, and he finished it. And then that is your whatever the browser you run in the virtual machine, Java V8. And then he started doing that. So finished another VM, which VM and language is better than JavaScript. But a VM or Java, another new language doesn't solve the business issues. So, and in 2015, the Dark Developer Summit, they introduced Flutter. So basically, it's a graphic stack or application framework that powers you writing an app. So now Flutter is very hot. So because it's cross-platform, so it cross the Android, Linux, and some other platform as well. So basically, it becomes a very close, and iOS as well. So it's cross-platform application framework, so people can pay attention to it. And back in 2023, so when I making my tablet and laptop, one guy called Joe, and he's from Toyota Connect, and Toyota Connect is working on the Automotive stack, the graphic stack. So, and we start paying attention to it, and at that time V8 and that isn't good enough to support RISC-V. So, and we been until 2023, we got Wasm and we got Dark backend to support RISC-V.
So,
Yep.
Flutter, is that a Yorkville layer?
Yes.
Okay.
Good. So, and Flutter, we have two versions. One is desktop version, the other one is embedded. So, and we call it embedded, and then Toyota are working actively because the reason why Android Auto is very heavy. So basically, if you run the full Android, then you need at minimum probably 4 gig of RAM or 8 gig of RAM. Now it's crazy, you know, everybody knows DDR killing people, right? So, and then all the automotive and the infotainment, they want to cut the hardware. So Flutter, you just need, I think on the ARM side, and at that time, Toyota working on it or Suzuki working on it, it just need 1 gig or 2 gig of RAM with embedded Flutter. You can get the whole UI working. So it's pretty impressive in terms of performance and sizes. So, and we pay tribute to Joe and leading this effort and getting the first Flutter release onto AGL. He called it Quirky Quebec. So back in 2025. And he spent a lot of money buying my laptop, tab, until we sponsor them on more on the hardware on it. So this is the AGL's release with the RISC-V support and Meta Flutter and based on Yato, Yato Linux. So people can get check on it and say hello to Joe and feel free to contribute. And this is state of it. So you can basically if you're AGL conference or automotive or like embedded world, they will show all the hardware running the whole infotainment or control based on the Flutter and on the ARM side, on the RISC-V side. So it's pretty amazed, you know, based on the time and effort, and it's pretty good, you know, very compatible, very competitive against Qt or Android. So, and what less actually for RISC-V, we just got the latest chipset based on the latest standard called RVA23. So there's more things needs to be done for the whole AGL plus the Flutter side, the stack. We need RVA23 build, and then we alongside with AGL see how we're going to support with all the hardware and get this over. And more importantly, because Flutter is built on top of 2 VM, so on the server side, basically they based on the JavaScript engine on Android platform, and then if on the Linux side, it's based on the Dart. So and both VM had to, for the performance-wise, especially for the drawing or memory movement, and this one we need a little bit of optimization work on the vectorized instructions. So, and need improvement, performance improvement. And then more and less now, because people know infotainment is going to have a lot of AI compute on it. And then Flutter just need another AI framework equivalent to on the website, like WebMN, WebNN, or WebGL, all these AI framework for the AI to know their local model onto the compute, and then to do all the AI work. So there's a lot of interesting activity going on if people have interest in, and we're still thinking how do we propose the API and package for the Flutter AI framework for local compute, which sit on top of a vectorized instruction and the future matrix instructions. So and even MPU. So people probably heard about Tesla with their latest chip coming out. I think it's the A5. They have a lot of AI compute. So how we going to we're similar to all other automotive MPU. So we need to find out how Flutter can do make use of the MPU on the AI age, especially for all different models. So you have Whisper for language, and then you have simple LLM or or you have a complex LLM talk to Grok or whatever, those things. So there's a lot of opportunity, especially for the AI age, and I think people can jump onto the project and the trend and learn something new about it instead of the old infotainment functionality, which is pretty boring, I would say that, and pretty fixed function, so easy to do. I think AI side is more interesting. Okay, so this is last page. You have read it on all the RISC-V project on Flutter. And then if you guys interested in learning the AI application for Flutter, then look through it. And then also, and you can try on the AGL release on any of our hardware, even the desktop or tablet, to play around with Flutter. And then once you have all the knowledge, and feel free to contribute all these improvement onto the open source Flutter, and which is actually a Flutter, even though from Google, but actually it's quite much more open than Android. So that's it. That's for today. Any questions?
Yeah, hey, is there a mic up there? Maybe
Yes, sure. Yeah.
I'll run the mic as well. I'll start with the first question.
Good.
So is Flutter? I assume Flutter's providing more of the UI. I mean, is it kind of an operating system? And then, but specifically, the reason I'm asking that is, where do you see RISC-V and/or Flutter on the edge? You're talking about automotive, but what about in like kind of edge? Because RISC-V is an inexpensive chip, right? Does it make sense getting as some sort of edge devices as well?
Yeah, I would think that, thank you for the questions, and basically I think if you can do automotive, you can pretty much do all the edge and anything with AI with the tops coming. And then the difference between RISC-V and ARM is that, and RISC-V chipset guy usually listen to the open source community more than ARM.
Yeah.
Because ARM actually, when you make a SoC, they already can ship KK volume. I would say that they already start making money. And when people making money, usually they don't listen, right? Why? Because I already ship 1 million a year. I don't want to touch
Right,
nothing.
don't interrupt the revenue stream.
Yeah, no, just exactly. Don't change anything, man. Otherwise, it broke, right? So that's why usually ARM's upstreaming is really slow. It's getting there, but it's still very slow. But in terms of RISC-V, it's still, all the ecosystem is not mature. They listen to people. So what do you want me to support you? And then that's why I did a talk back in the Ballroom C, talk about kernel upstreaming. It's just, we broke the record. We start upstreaming before the chip comes back, right? Mm-hmm. And the code is very compiled. It can't run, but it's already breaking the record because we listen to the community. If you don't upstream and you don't have features, the more you change it on your branch or LTS, the harder you're going back, right? So that is the advantage of RISC-V. We listen to, not you guys, right? The reason, probably I'm the only hardware guy doing a lot of talks on the open source community, because I want you guys contribute, and want you guys listen, and want you guys to earn money of it and spend money of it. Right? If you guys spend money on RISC-V, you know the pain. And then if you spend money buying deep computing stuff, I genuinely listen to you to death. You can beat me to death. And then I will fix whatever you ask me to fix. And if not this generation, with last generation. And then I give you rebate back to make RISC-V better and better, to achieve the vision of this.
Cool. Any other questions? Here, because if you put them in the mic, then they'll get in the live stream.
So I had this misconception that, Flutter, because it's Dart, like required JVM, and I just looked it up and it doesn't. It requires a Dart VM, which I didn't know was a thing. So does that mean that there has to be a Dart VM compiled for RISC-V for Flutter apps to run?
Yep, everything is supported.
Okay.
Dart, so back to the table. Dart is supporting RISC-V. It's well earlier than 2023, but it's just not optimized.
Okay.
So basically, now it's already everything's running. You have Dart. You can compile it to WebAssembly, but you still need a WebAssembly VM. So the WebAssembly VM is usually V8 or Node.js. So and it's all VM based, dynamic and language based.
So I was reading about the Dart VM. So you mentioned you can target WebAssembly, but normally like on mobile, when you compile Flutter apps, it's ahead of time compiled into native code for, the ARM that.
Yeah, and they have certain thing can ahead of time, certain thing you cannot. So basically, you still need a minimum VM running.
Okay.
So,
For
but
the
that's
things
very
that-
lightweight. And basically now the CPU is fast enough. You don't need to compile; it still runs very fast.
Okay.
But it just if you optimize it, you usually get much better performance.
Okay, so not everything is ahead of time compiled. A lot of it is still JIT compiled.
Yeah, yeah.
Anybody else?
So for these sorts of automotive applications, is there a requirement that these processors have to have some degree of radiation tolerance, or not? Can you kind of speak a little more to that? And then if so, are there radiation tolerant RISC-Vs being manufactured at this point?
Yeah, yeah. You can go to the RISC-V booth or deep computing booth or framework booth. You can see all the RISC-V is running there. So you literally can touch it and feel it. Okay.
And then one last sort of,
Yep.
do you envision a sort of relative marketplace for RISC-V alongside, say, Longsun, or you think that other architecture?
Well, I would say that just like Linux, you'll be alongside with FreeBSD, alongside with anything that provides human variety. We're saying that we coexist, isn't it? So, and we don't tend to replace anything. It just gives people a lot of options. With all, especially we targeted where we becomes the best Linux-based architectures. So I leave the freedom to people to do all the implementation on the industry in the industries. Yes.
Can you hear me?
Yep, sure.
Okay. Could you clarify the state of the NPUs with RISC-V? I've seen RISC-V chips with embedded NPUs in them.
Yes. Yeah.
Are
For
those
example.
all the-
Yeah.
What's the deal with that? If it's not part of the RISC-V architecture.
It basically is just like coprocessor. So they have a separate IP for the NPU. So because RISC-V is still in a growing stage. For example, I'll give you an example here. Why we have an NPU? Because the profile, the matrix profile instruction, the specification not been out yet, not been ratified yet. So people cannot implement it. Once this one implemented, we think the NPU will die out because this is a completely different instruction. It's not inside the spec. So, and just we see NPU might be an interim of thing, and and the software stack you still probably do support for a while. Because usually a spec coming out will take 1 or 2 years for the chip to go. The spec comes out, and then the IP comes out, and then the SoC comes out, and then the board comes out. Usually take 3 to 4 years.
So these manufacturers are creating SoCs, RISC-V,
Yeah.
with NPU.
Yeah.
We have no idea what instruction sets they're using.
These are all
Really?
proprietary instructions.
Okay.
Yeah. So, and you will see, and feel free to come to the RISC-V community booth to take a look, or the video on YouTube, how you know the large language model or Whisper, whatever, all run on the NPU, on the RISC-V laptops. So, thank you.